Okay, another question that was asked over email. You're asked to expand x minus 9 to the fifth, and this is problem 11.5.21. And so the way that you can expand these is using the binomial theorem, and you probably want to use Pascal's triangle in combination with the binomial theorem to do this. It's probably the easiest way to do it. So the first thing is just briefly about Pascal's triangle. Pascal's triangle is this. Start with a 1, and then you have 1s on the outside, and each of these numbers, this 2 right here, comes from adding those 2 together to get that. This 3 comes from adding this 1 and this 2 to get the 3. This 3 comes from 2 and the 1 to get the 3, and so on. And you have 1s on the outsides. You notice this 4 comes from 3 plus 1. This 6 comes from the 3 plus the 3, and so on. Okay, so when you build Pascal's triangle, these numbers are going to be the coefficients of your expansions just in the generic form without anything else going on. Okay, so the binomial theorem says this right here. Says that if you have x plus a to the nth, it's equal to the combination of n things taken 0 at a time times x to the nth plus n things taken 1 at a time times a times x to the n minus 1, and then so on. So basically what you're doing here is you're decreasing the power on x by 1 every time until you get to none of them, and then you're increasing the power on a by 1 every time. So, and then you also just are dealing with whatever this power is. 5, you know, in our problem it's a 5, so it's going to be 5, 0, 5, 1, 5, 2, those combinations. Turns out these combinations correspond to the Pascal's triangle 5th row here. I guess it's the 6th row, but that's the 5th power Pascal's triangle. So, okay, so the way we're going to do this problem is we're going to first of all say, rewrite it and say that this is x plus negative 9 to the 5th power. And that's so that I can see that my a is actually a negative 9 and my n is 5. And the a and the n that I'm talking about are the a and the n in this formula. The a is it's x plus whatever that number is. So a is a negative 9 in our problem. The n is 5. Okay. So this is going to expand into 5 things taken 0 at a time times x to the 5th, and then plus 5 things taken 1 at a time, and we have a negative 9 to the 1st power, and the x descends by a power. This same pattern holds on all of these. Okay, and then we have 5 things taken 2 at a time, the negative 9 taken to the 2nd power, and then the x to the 3rd power. So notice that x is diminishing by 1 every time. The negative 9 is going up by 1. You could think of this over here as like a negative 9 to the 0 power. Anything to the 0 power is just 1, so we're not, we're missing that there. And then we're just going to continue. This goes 5 things taken 3 at a time times negative 9 to the 3rd power and x to the 2nd power plus 5 things taken 4 at a time, negative 9 to the 4th and x to the 1st, and then 5 things taken 5 at a time, negative 9 to the 5th and x to the 0 power, which is just a 1, so we don't write it there. Okay, now like I said, these right here, the 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, and 5, 5 are going to correspond to Pascal's triangle right here, to these coefficients. Okay, so instead of doing out these combinations, I'm just going to use Pascal's triangle right there. And I'm going to say this is actually equal to 1, and that's this combination 5 things taken 0 times that 1 times x to the 5th plus 5, and that 5 is this combination right here, 5 things taken 1 at a time times negative 9 x to the 4th plus, I'm now going to have a 10, that's a combination of 5 things taken 2 at a time, times 81, that 81 is the negative 9 squared, x cubed, and then plus another 10, that 10 is a combination of 5 things taken 3 at a time. Negative 9 to the 3rd power is a negative 729, and we have x to the 2nd, plus going back down to a 5 for a 5, 4, And the negative 9 to the fourth power is, I believe, 6,561. And then plus a 1 here for the combination of 5 taken 5. Negative 9 to the fifth power is, let's look, I don't know, 9 to the fifth. So it's going to be a negative 59,049. Oops, can't see that. Sorry about that. Okay, so let's just simplify this. This is going to be x to the fifth from that right there. And 5 times negative 9, that's a minus 40, x to the fourth. 10 times the 81, that's 810, x to the third. 10 times the negative 729, that's a negative 7,290, x to the second. Oops, I forgot an x right here. This one should have an x on the end, that x right there. And then we have 5 times the 6,561, so we get plus 32,805x, and then minus the 59,049. Okay, so that whole thing right there would be the expansion of x minus 9 to the fifth, and that's using both the binomial theorem, this is all the binomial theorem, and then I used Pascal's triangle to do these numbers, 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, and 5, 5, instead of using combinations on them, because I noticed that they correspond. Okay.